Hello there, YouTube. All right, here we are. This is Michael. We are doing an immutable book club, talking about the Art of Immutable Architecture. This is also a Janaga stand-up, so talking about open source projects that are based on the ideas found in the Art of Immutable Architecture, and trying to build a set of immutable runtimes, a set of tools that will help us to build systems, distributed systems in particular, based on the concept of immutability and as it applies to nodes within a distributed network. So the book club is set to start in about 5 minutes. So as folks join, we will have a discussion there. And if you are joining in the chat, then welcome in the YouTube chat. Please leave your comments, say hi, tell me where you're from, and tell me how you came to learn about the Art of Immutable Architecture. So I have been looking at a post right here. Sergey has posted a link to Dr. David P. Reed's dissertation. So I was taking a look through that, and it appears to me that there is quite a lot that I need to catch up on there. But it looks like Jan he's coming in.
Michael.
How do you do, Jan?
Good to see you. I'm just in time.
Indeed.
My wife is a very fast rescuer.
Good feature to have. Yeah.
No, I went to collect my daughter from the rail station, which is 10 kilometers away from here. And then on the way back 5 kilometers from home, I got a message on the board computer: engine failure, stop engine immediately. So I'll just put the car aside, call my wife to collect me, and the rest is for tomorrow. So we will see.
Wow, goodness.
Yeah. These days they put so many sensors in the car that because the engine was running fine. So, and I checked the oil level recently. There should not be any problem. Probably one of the sensors that.
Yeah, you need triply redundant sensors, actually quadruply, in order to really be truly sound. And then you have a minority report. It's like, no, that sensor is reporting something different than the others, so ignore it. And yeah, they probably don't make it that extreme in the engineering of automobiles.
Well, for Apollo missions they do, but for cars, now I think if they would put it in mass production like they do today, it would not be much more expensive.
Yeah, probably not. Looks like Roberto says hi on YouTube. Good to see you, Roberto. Yeah, by the way, I am streaming to YouTube now rather than Twitch, since YouTube is where the the audience comes eventually anyway. Well, let's start them off there. And it'll still give us the immediate access to the archive, but it'll also retain that archive for a longer period of time. So I think it'll work out better.
Okay. So we can review it afterwards on YouTube immediately, like we could on Twitch.
Yes,
all right.
Indeed.
Because it's sometimes useful.
Yeah, and I'm afraid last week I was not able to join. So we had a bit of a medical emergency. My wife's mom needed to get to the hospital real quick, so it's like, okay, we'll skip this week. We'll go on next week. But, yeah, she's doing fine.
She's fine now.
Yep.
Okay.
Yeah, it
No.
gave us a bit of a scare.
Yeah, things happens. That's worse than a car. Yeah, but and good, all good, huh?
Yep. Yep. Indeed.
No, around 8 o'clock local time, David came online as well.
Oh
So
yeah.
had a little bit of a chit chat with David. We just talked about, and I could also give him some pointers to videos of you on YouTube that would be interesting for him. So I think it was interesting to hear what he was doing, what he was looking for in historical modeling, because he's more technology focused than really direct an application. But
right. Yes. Nice.
mm,
Cool. Yeah.
but
So yeah, hopefully we'll
I
be
guess
able
yeah.
to join us again today.
Mm-hmm. Michael, before they are there, a few questions, because I've still been busy on React, because then I think they are there.
That's all right. Go ahead.
Yeah, I've still been busy on React because then to understand your projections, which I still don't completely understand, part of it, yes, but then I saw it is using use ref or something like that, which points to React hooks. So there we go again.
Yeah.
But I'm not through it yet. But the time before, hi David.
How do you do?
Hello, Jan. Hello, Michael.
Good to see you again, sir.
Good to see you
Everything
too.
all right?
Yeah, sure. Yeah. Sorry, I'm always 1 minute late. I apologize.
That's quite all right.
So Michael,
the React hooks are a whole new research project in and of themselves.
I will get through it, no problem. But the time before last time, I had that question about how the technician could become member or make himself known to the company. Yeah. So I've been thinking a little bit further, and actually, I think the companies, because a technician, he can download the application. He will be able to register even without working for a company that uses the application.
Yes.
The purpose is that, for sure, for independent workers, that they can make themselves available to companies. They can say, look, tomorrow and the day after, I'm busy already, but from next week onwards, I'm available during these days. If you need somebody, please hire me. Yeah, that would be an added value for my software.
Yes, yeah, indeed.
Now, I can imagine that a lot of technicians or workers, they might say, yeah, I don't want my personal data to be available to all the companies or who use the application. But on the other hand, the companies, they might say, if we look for people, we will just say, okay, around that location, we have work to do in that area. For example, a circle of 30 kilometers around it, we look for people there for that job. And that at that moment, they see all the technicians available during that period for that job.
Yes, yes. So that sounds to me like it would be a great application of a search technology like Elasticsearch that supports that location-based searching and indexing based on different attributes. So that's probably not a query that you would want to run directly from the model, but instead you would want to project that into Elasticsearch and have it run from there.
Yeah. Because I think we can, as long as the number of technicians is below 1,000, it should not be a problem, I think.
If you wanted to query from the model all available technicians and then just run that search in memory, that's one way to do that.
But if you would go to 10,000 or 100,000 technicians, then it becomes complicated. But okay, there we will find solutions. For the moment, the problem is, how do they log in? So actually, a company, I create the companies because they have to pay first to use the application. So that's not a problem. I make a login for them. The technicians, they can log in themselves. Now, the whole history of a technician stays with him. So first I thought a technician can only log in one time, and I have to be sure that he doesn't make a fake account.
Right. Yeah, that's always a challenge.
But if I want to accomplish that, for example, I know in Belgium, the Belgium IDs, they have an electronic ID. So we can use our ID to log into a website of the government and to ask for official papers. So that's with a chip inside the ID card. But that's something which is Belgium only. Right. In Holland, where most of my customers live, they have a similar system, but it's different. It's a different technology. And I think in Switzerland, they probably also have it, David, but it will probably, again, be a different technology. So if I want to interface in that way, it's going to be complicated.
Right. Yeah, and I think that that's for other reasons probably something that you'll want to avoid. I mean, certainly it's problematic because it is specific to the population from which your user is coming. But yeah, for example, here in the States, there's a very big pushback against that sort of a government ID system. So what we have is very weak related to compared to to what you're describing there. People don't have a chip that is somehow attached to their identity, and so any sort of requirement to have that is going to be problematic for a number of reasons. Portability is a big one. Also, now you have a dependency upon an external system that you don't directly control. So if they change the rules, then it's difficult to update. Diversity and inclusion. You want to make sure that people can participate in your ecosystem without having to go through some additional requirement, and you have no idea why they wouldn't be able to. So, so for those reasons, that you just don't want to accidentally exclude people.
I can imagine that, for example, somebody is hired for one day as an independent person. He arrives at the company. He hasn't made a login yet. And then they say, yeah, you have to make a login. And his ID card, he left it at home. So you get into trouble. What I could do is just allow them to make a normal login. But that means that they might also make a second login. And at a certain moment, we will have to merge the two identities.
Yeah, and that would definitely be a problem. Thank you, Roberto. Roberto notified me that my audio was pretty low, so corrected. Thank you very much. And so a second government identity for the same person, that's obviously going to be difficult to accomplish. So that could definitely be a problem. Now, if the identity system that you're trying to integrate with was also related to the domain, in that, for example, you needed to be able to pay somebody or withhold taxes, then you might need that additional identity for that purpose. And so then using that identity also within the application might not be a bad idea.
Yeah, but I think everything that has to do with taxes, I prefer to leave it out of the application to keep it simple. I prefer to connect to other software that does the invoicing and the taxes, because that changes all the time. But so pure for my application, people need to log in. And so if they make a second account, at a certain moment they might say, we want to merge the two accounts to have all the history together, or for whatever reason. So in that case, I just allow them to make an account by entering their email, choosing a password, and that's it. Or, for example, using their Google identity or Facebook identity or Twitter. That might be another possibility. But so they might make more accounts.
Right.
So once somebody has an account in historical modeling, so he's at the top of the tree, he has a bunch of history below it, and then he creates a second account and a bunch of history. And how do we go about merging them?
That is definitely a tricky problem. And this actually might be a good opportunity to bring in some graphics. So I'm going to share share that screen. Okay, now we can do some graphics, and then yeah, it looks like everybody on the video will be able to see it as well. Okay, so let's create a graphics digraph. So then I like to start these with rankeder equals BT, so all the arrows point up. Okay, so you've got this user idea. I'll hit Control K V.
Yeah.
Now we've got our user over there. So the user is the top level object that you were just talking about that has the public key is the only field, so it uniquely identifies that user. And then you would have a different ways to authenticate. So there might be a Google identity, which is a successor to the user, and then a government identity, etc. So these are different successor objects that can get you to that user. Now, so digging into that a little bit, when you log in with Google, Google is going to have some sort of a unique identifier for you. Now, if that unique identifier is inside of Google Identity, then you couldn't find it because it has a predecessor of user. So you would need to know the user's public key and the Google identity in order to find that object. So it's not exactly like that, but it is more like we'll call it like this. So you've got Google user is a Google identity, is the join between a Google identity and a user, and a government user is the join between those two. So now here at the top level, just with Google's unique identifier, you just put that in there as the field, and that uniquely identifies that fact. And then you can search for successors, find the Google user successor that relates that Google identity to a user, and then jump back up to the user. So, of course, by doing that, you could end up with multiple users because you'll have multiple successors. There's no way to guarantee that you're going to have only one successor. So starting there, that allows you to have multiple identities for the same user, That doesn't exactly solve the problem that you were going for, though. So the problem that you were going for is that, and we'll go ahead and now give these specific identities here. So this is no longer truly a fact type diagram. This is now starting to morph into a fact instance diagram. But so you've got user 2, and you've got some history associated with user 1.
Yeah.
Okay, so now you they have.
And user 2 could, for example, log in with a Twitter identity.
Okay, yeah, let's go ahead and do that.
Yeah.
Okay. Yeah, so you've logged in with Twitter, and you've started collecting history. You started using the application, and then you say, hey, wait a minute, this other history isn't here. What's going on? So that's when you'll want to be able to create some sort of a merge idea that says that that these two users are intended to be the same user. So there's a couple of ways that that you could solve for that. Either have the foresight right at the beginning to know that that's going to be an issue, and then if you think about that ahead of time, then all of your history can be related to that that one I guess identity that's separate from the user themselves. So still a bit tricky. It doesn't fully solve the problem because you start with you still have to be able to merge things after the fact, and so successors are the way that you merge things after the fact. So so with this, the queries just start to become a bit more involved, and you start to merge your query results together. So if somebody is logged in using Twitter, and so now you have identified them as user 2, in order to show their history, you'll want to query not just for the successors of user 2, but you'll want to go to the successor merges, then all of their predecessor users, and then from there query the history. And that will, in that one query, because you're jumping down to merge and then back up to the user, it's going to perform that that merge across all of their different identities.
Yeah. And another possibility would be to rewrite all the facts if we don't use encryption.
Mm-hmm.
And in that way, we might get normal queries again.
Yeah.
What do you think about that? If we, for
Yeah,
example, somebody say, okay, I want to change. First, I made user 1. Then I started working as user 2. And now I want to abandon user 1 as a login, but I want to get his history in my user 2 account.
Mm-hmm. Yeah, I tend to shy away from the idea of regenerating the facts under a different user account or different conditions, because that's kind of an irreversible operation. So right here, I mean, it would be kind of bad if you merged two users that turned out not to be the mergers that you intended, or the users you intended to merge, but at the very least, if you do do that, you've got this option of adding another successor here that that says, okay, they're not merged anymore,
Yeah.
and their histories go back to being independent, and you no longer have the duplication, the copy of history 1 inside of user 2's history. So yeah, it's just that for that that duration that they were merged, they could see each other's history, and this also has the advantage of if you're logged in as user 2 and you record new information, that's going to be recorded in user 2's history. And so even though user 1 would be able to see that because of the merge, if you deleted that merge, then they would no longer be able to see it, and you would attribute the history to the correct user.
And after an amount of time, the old information, because if the user continues to use user 2 account, after an amount of time, the old information which was stored on the user 1 might become less valuable. And so finally, we don't need to make these big queries anymore.
Right, and that's why it would be a really good idea to have a period pattern right here.
Yeah.
So so now you gather that that history within the period, and then so okay, you want to go ahead and migrate over to a different identity, and rather than having that identity point back to this original user, somehow when you set it up, you got a new user. Okay, that's fine. But yeah, you start accruing history under this new period. Eventually, you don't care about these old periods, and they kind of fade from view.
Okay. I think that solves my problem. Then I still had a second question. So the workers, they have two ways of making themselves available. They can say, okay, I'm available during that period, and here is my complete curriculum. All my I'm specialized in that. I have these diplomas, I have these certificates, and they make everything public. So a company that searches in their area will immediately find them as a candidate. I can imagine that some workers say, no, I don't want to make all my certificates available and all the things that I can do, but I want to be notified when a company searches in my area. And then I can say, okay, make my details available to that company. So that would be a way to make them known to each other. And then the company can say, okay, we will hire you, and he confirms, and from that moment onwards, we have a link between the two. But I can also imagine that for one or the other reason, the link is not made. And the guy in the morning, he comes to that company and he say, oh, I already have an account. Please activate me, dispatcher. Please connect me to your system.
Yes.
But there, so for example, user 2, he has a public key, but that public key is much too big to display on his screen and to communicate. So we might have the hash of the public key, but the hash will also be quite big. So we might have a kind of the hash of a hash, which is, for example, 6 digits long.
Yeah.
And
so
so
like
the worker
of the hash,
communicates that number of 6 digits to the dispatcher. The dispatcher enters it, and his name shows up.
Yeah. So that's to accomplish that. I think that would also be going outside of the model. So yeah, I've tried a few matchmaking algorithms and patterns within a model, and found some. They pretty much all run into the issue that you have to publish. One side or the other has to publish, and then the other side can just see everything, and then ask for an invitation. And so that can all be done within model, but the the use cases that you're describing are really best served outside of the model, where you take you put something into a search engine, and then you can find it. So it could be like the first use case by location and based on your skills. But then this other scenario is based on the thumbnail, the prefix of your hash. So yeah, you just put that into a search engine, so you index it by that prefix, and so somebody can look that up and then get the full public key, and then go back to the model and make the the connection that way.
Yeah. So in that way, you would say we provide that as a service on the server, a kind of API, so that the company has to be working online to retrieve that data?
Yes. Yeah, I think so.
Okay.
Yeah. Yeah, unless like you were saying before, the numbers are pretty small, and you can go ahead and load the entire list into memory on each device. Then it makes sense to, okay, let's do a query. Let's find all of the users who have published, and then I'll go ahead and compute the fingerprints for each one, and then look it up in a table. But ideally, ideally I would say it's an offline, out of model, out of band solution.
I hope for a lot of users, so I should prepare for a lot of users. Okay, I will think about that. I think with that information I can continue.
Excellent. All right, where's that? There's the stream. Okay, cool.
Michael, there was some information on your screen about nursery. I don't know what it is, and I don't know whether you want it to be on YouTube.
Okay. That was it already made it out to the live stream, but we will.
But you might want to delete it from the archive.
Yeah. Yeah, but I don't think it's going to be an issue. Because the information that you just saw is going to be public very soon.
I don't know what it was, but okay.
All right. So, David, I hope that that wasn't too specific to what we were talking about there. We did touch on some of the patterns that came up in the book. So, hopefully that was a good example of how to apply some of those patterns.
Actually, this. So I had a question. So I just finished location dependence the past few days, and I have a question.
Sure. Which
I think sort of you touched it when you were analyzing Jan's problem. That so I have this bunch of facts that are connected by their causal relationships, and so if someone gives me this set of facts, that how do I start navigating in this graph? And I believe, so this is sort of, I think partially you answered this, that I sort of need to have some sort of anchor point where I can enter into this set and then try to traverse the interesting parts.
Right.
And if I understood well, then for example, this in this previous example, the user ID would be the starting point in this specific example.
Right. Yes. Yeah. So I've solved that problem in a number of different ways in different systems. So one of the ways to do that is that, especially if it's a website that you're starting from, is that the website itself has a domain. I usually use the actual domain name, or I might use production and QA and development as different identifiers within the system. And so one of your root level facts is is domain, and it's identified by that string. And then when you publish the site, when the browser downloads that initial HTML, that includes a small JavaScript object that is just that domain fact. So it's got the string embedded within it. And so even if that domain fact is created by a user, and so it's got a reference to a user fact with a public key, so you have a really small graph, it's still easily representable in a JavaScript object. So you've got JSON for the domain, and then within that you've got a field which is user, and then that's the JSON for the user containing the public key. So then you just express that as a fact within the model in Janaga.js in this particular instance, and then all the queries work from there. You've got your starting point. But yeah, if it's a mobile application, then your starting point is typically going to be the user themselves. So you start up the mobile application. Okay, you need to create an account or log in. So you go through that exercise, and now we've got a user object with a public key, but nothing else. So what do you do? And that's when you can call another API, go around the model, go directly to a server that you've got some indexed information. Do a search there, pull back a record you're interested in, and that contains the fact, and that's the ID, and then you start querying the model from there. So it requires you to be online for that first part, but you're usually online for that first part anyway because you're setting up an account.
And if I may have another question.
Sure.
About this chapter, is that so the chapter, so location dependence, chapter 4. So it starts with your experience with the contact synchronization system. And I'm really sorry that you haven't sold a single copy of this system. I find it really nice.
I learned quite a bit on it, though.
So one of the interesting part for me was the replaying history.
Mm-hmm.
That you build up this this elaborate scheme and then correct scheme of accepting mutations of contacts, so like simulating contact changes.
Mm-hmm.
But then you say that, okay, so this is all fine, but then a new device is connected to the system, and suddenly all the history is being replayed on the device itself. So I find it really illuminating this this part, and I guess so then you talk about state-based CRDTs, which is, and I think what I got from this chapter is basically here you argue that the historical model is a CRDT.
Yes.
Is it the right conclusion?
Yes, that is correct.
And I guess so then my question is then, so how would we solve this problem with the replaying history in front of my eyes, so that I have an empty device, I have my contact history, so I'm connecting to the server. So like what are the sort of API calls that happen, and what sort of data is coming from the wire?
Yeah. So so first of all, that problem of replaying history is one that other systems have tackled and have solved in different ways as well. So it's illuminating to see how others have approached this problem. So in the case of event storming, one of the event sourcing, one of the proposed solutions there is to have a snapshot of an aggregate at a certain point in time. So now you're just replaying history from that point forward, and so that is kept at an aggregate level, and so there's a stream per aggregate. One of the mistakes that we made in this system is that there was just one stream. It wasn't a stream per aggregate, so there wasn't a stream per contact within your system. This was just a stream for your contact list. So that basically you had to play through a lot of that stream before you even got the contact that you're interested in. And so that was the the big crux of the problem. And so then by having a separate stream per aggregate, and then also having a stream that that basically just represents the additions to the book itself. That allows you to go through a shorter history and get all of your information, and then start playing the histories of those individual aggregates as you need them, as you become interested in them. And then you could say, okay, I want a snapshot of the book, and so that's just a list of goods or something. And you say, okay, there we go, it's brought in. And so that's that is one approach for solving that problem. And so now take that to historical modeling, and the thing that you kind of learn from that is that that history is not just one one continuous stream, that that you can look at subsets of your graph, and so with the historical modeling approach, with that being a directed acyclic graph, now that becomes a there's a mechanical way of looking at that. It's if you compute the transitive closure of your predecessors, then you get a subset of a directed acyclic graph that is itself a directed acyclic graph. And so that is a consistent set of information. So long-winded way to get back to your question, what do the API calls look like? So the API calls look like that you express interest. So later on, goodness, it's like chapter 11. It's where we talk about query inversion. No, that's chapter 9. Chapter 9, yeah. So in chapter 9, we start talking about pipelines. So you describe a projection of the the shape of the information that you're after, that is turned into a pipeline. That entire pipeline is then sent to the server, and the server says, okay, what is the subset of the graph that is necessary to compute this pipeline? And then it can just package that that subgraph up and send that back to the client. So so that separates the idea of the the communication mechanism. So it's not that each individual fact is a separate message. Instead, you can send a whole graph. But then that's computed separately from the actual pipeline itself. So so now you've got that graph. You start sending that information back. Zip it, chunk it, whatever network mechanism you need to make sure that it gets delivered, and then unpack it and put it into the graph. And now the client can run the pipeline, get the results, and display them on the screen. And it can do that for a subset that represents, for example, the start page. And then once the user navigates in, now that produces another pipeline from a specific starting point, and then that goes back through the process and merges it into the model on the client.
Okay, thank you.
Yeah. Yeah.
And so maybe just a last question, which is a bit more broader. That so basically, embracing immutability is an orthogonal decision. We have one axis, which is to say we embrace immutability, which is generating new facts, and we sort of accrete information. And there's another decision, which is how do we architect our systems? And these are orthogonal in the sense that I could have we often talk about client-server architectures, but this could be also peer-to-peer. Do I feel this right? Is it fair to say that?
Yes. Yes.
The way we model information is not doesn't necessarily influence how we architect our system, but maybe with immutable information model, we can architect, for example, a peer-to-peer system that would maybe perform better than.
That is absolutely the goal, and something that I hope that I've been able to stick to as closely as possible. Now there are some places where the two ideas do get close to one another and start to intermingle. So when I talk about regions within a historical model, I'm talking about a region of responsibility. So a particular actor, a particular kind of user is going to create those facts. But then I use regions in order to analyze how a system can be broken up across different nodes. So you know that one actor, like the conference app is what I use for this example. One of the actors is the attendee of the conference, and so they're going to be on a mobile device, and so the facts that they create are going to come from that mobile device. And another one is going to be the conference organizer, and another one is going to be the speaker. And the conference organizer is going to be using a website, and the speaker is going to be logging into that same website, but with a different login and different set of permissions. So I used basically that's one place where the analysis started from the purely abstract, just look at the information, don't look at the architecture, but then it also informs the architecture to some degree, and some architectural decisions kind of leak back into the model, and you can kind of see where the region boundaries kind of line up with the machine boundaries. But yeah, definitely I don't want to try to solve problems using the machine boundaries. So I don't want to solve a consistency problem by using topology. So yeah,
because that does change.
Yeah, exactly. So insofar as you can keep them separate, it definitely helps. Yeah.
Thank you.
Welcome. Cool. Yeah. Yeah, I like the basically both of those kind of touched on one of my favorite parts of doing this kind of analysis is that the analysis is based on an abstract idea that can be applied to more than one problem, not just the thing you're looking at. So kind of taking it back to the event sourcing snapshots. You have to kind of make a decision. How am I going to optimize my system? Am I going to take more snapshots or fewer? And so the problem itself doesn't tell you what the answer should be. There's no mathematical formula that says this is the one right answer. Instead, you kind of design it to do the thing that it needs to do. But as far as historical modeling goes, it tries to tell you the one right answer up until the point when it's now completely in your hands and you just take over from there. And I've tried to make it such that it's the same set of rules each time. Like one of the examples that just came up during our first conversation is that when you have a successor query, you cannot guarantee that you're going to get just one answer. So you log in with your Google account, because we're using a successor to get back up to the user, you cannot guarantee that you're going to only have one user. Even though you probably coded this system such that it says, okay, I saw a login, now check my database. Is this already associated with the user? No? Okay, go ahead and create one. Yes, use it. And so you might think, okay, it's always going to have just one because I coded it that way. But you don't have to think through the scenario of, well, you know what, this is probably going to be in a cluster, and so what happens if somebody logs in, but then that one that one response that they get from Google, here's your token, okay, redeem the token, if that is the one message that is duplicated and goes to two different machines within the cluster, and they both create users, so that's one of those edge cases that you might not even think about. But you can always say that if you're doing a successor query, you can't guarantee one result. So that's what I'm really excited to see. And in fact, so I was just looking at Concordant. I discovered Concordant through a tweet from, actually I don't even remember who the original source was, but I was like, oh, okay, this is where a couple of the people who wrote the papers on CRDTs, what they're doing today. So let's check out what they're doing. And in there, in the API, there's a collection object, and so you can say, okay, I'm going to connect to this collection, and I'm going to write objects into the collection and then read them back. And the API for the collection does not guarantee that it's going to give you back one result. It gives you back a set. I was like, yes, it must be. That's how information works. So yeah, that's just a universal truth, and so I love capturing those and making them the same universal truth everywhere that you want to apply them, and then you just follow the rules.
Have you been playing with that API from Concordant?
I haven't installed it yet, but yeah, I kind of read through the Sudoku example and saw how it worked. I was actually kind of tempted, although I think I'll resist this temptation. I was kind of tempted to, first of all, watch their version of it running, and then take the same starting point and make the Janaga version, because it's TypeScript. So it would be kind of fun, but I don't know what I would learn from it, so I'm a little reluctant to run the experiment.
Because I just saw the website, and I saw that they have three examples, 3 demos.
Mm-hmm.
I'm a little bit sad that it's not really line of business applications.
Yeah, I mean, just like my original correspondence demos back in the day, they were all games, because that's what I was really using it to write. I was doing games for mobile.
But then you came up with the Pluralsight courses,
mm-hmm.
and that was a service worker application that you proposed there.
Yep.
And I think.
And my original plan there was to use one course to introduce you to the idea of an occasionally connected mobile application, and then have additional courses that show you different implementations of it. So the parse course, which you may, I don't know if you watched the
but
parse
that was
one.
before the other courses. That was the first one, I think.
Was that? Maybe it was. Yeah. Okay. So it might have. Yeah. Wow, memory is a funny thing. But yeah, I was thinking, at least I think I was thinking that I would show how to build these kinds of systems using parse, and how to build them using just the out of the box component, so kind of build your own. And that's what the Rover Mobile toolkit basically came from.
Mm-hmm.
It's like, okay, let's just take patterns, and we're using the same patterns over and over again. Okay, I'll put them into a toolkit so that it doesn't become too redundant. But yeah, then one of the courses was going to be, and this is how you do it in correspondence. But yeah, I really didn't get very much uptick on, certainly not the parse course, because then Facebook bought it and killed it. But the other course didn't really do all that well either. Or that was 3 courses then, wasn't it? My Windows Mobile trilogy. I was showing different kinds of mobile applications, and so one of them was line of business. Yeah.
I think then you started off with Jinaga.
Yeah.
In the videos outside.
Yep. Yeah. So that took my attention and my energy. It's like, okay, people don't seem to be picking this up. Maybe it's because of Windows Phone. Oh, and then sure enough, Windows Phone, dies a very slow death starting from about that point. It probably started earlier, but I just refused to see it die. But getting the right, getting the attention of and building an ecosystem is that's the hard part. The math is the easy part.
I don't know whether the math is the easy part.
Well, at the very least, the math is the done part. You can just read a paper and say, okay, there's the math. Yeah, there are really smart people working on that. And yeah, so it makes me happy when I see those really smart people are working on things that we can apply to our own systems. And so, yeah, I was looking through there seeing, well, what's the flavor of the API? Because with Janaga, one of the big problems is that it forces you to think differently. It doesn't try to adapt our usual way of thinking into a distributed runtime. And so I've kind of been casting about for how other people are solving this problem, and some of them do put the typical way of thinking on top of a distributed runtime, but then they will invariably run into the same problems. So typically that's the problem of resolving conflicts. So that was I think Parse had Parse was one of those that it was making it look like this is just a simple database. So it's time for Jan's connection to reset.
I'm back. I thought we made it 15 minutes now before it reset.
Yeah, it's getting better.
But I got a few images green. I say something is gonna happen, but finally, don't know why, but
But yeah, so it looks like Concordant also changes the way that you think about things. So it's like, okay, here's an interface. Beyond that is CRDT world, and then on this side, you get to code by adding things to collections, and then you can query those collections back, and the collections behave in really weird ways that if you don't understand what CRDTs are doing behind the scenes might be confusing. But but once you get it, it's like, yeah, of course, that's the only way that they could behave.
Yeah, but if you only work with collections, you still don't have the, like in historical modeling, you have the causality between facts.
Yeah. So it looks to me like the causality must be there, but they are taking that and using it within their own data structures. So like in the Sudoku example, you can have two people playing Sudoku, filling in the same cell with a different number, and then they will eventually each see each other's number, and it will just show both numbers in the cell. But now if you're seeing two numbers in the cell and you put a value into the collection that says it should be this one number, then the collection will now converge to that one number. It won't give you two numbers or three numbers anymore. It'll just give you that one. So behind the scenes, basically I'm thinking it must look very much like the mutable property pattern. So the causality is being captured and exchanged. It's just not exposed to the application developer. And yeah, I like to not only expose that to the application developer, but okay, this is your toolkit. This is what you use in order to design your applications. So yeah, let's not sweep causality under the rug. Let's code with it.
Yeah, because if you don't expose that to the user, then he cannot use it anymore to make analysis of the problem.
Yeah, and that's what I enjoy doing. Like we just did at the beginning of the call here. We analyzed a real problem using causality, and then then it becomes pretty simple to see, okay, this problem that you're trying to solve doesn't work with causality, the fingerprint thing. So let's solve that a different way, and then bring it back in. Now you've got very small dependencies on external systems. You've taken just parts of your problem and offloaded them to something else, instead of trying to find where that line is by analyzing the performance of your system, or having built it one way and then saying, oh, that's not working because it's got a whole bunch of defects, let me rebuild it another way. You just analyze it according to some I think simple rules. Other people disagree. That kind of goes back to, I wish that there was a fundamental definition of simplicity, and I think that there is, but we might have already discussed this, that the number of bits that it takes to encode an idea is proportional to its complexity. So a simple idea takes just a few bits to encode, even if it's not familiar to the person receiving it. But then that means what alphabet are they using? Anyway, that gets into Claude Shannon's work, and that's fun stuff.
There we get back to information theory. Yeah.
Oh, cool.
Oh,
All right.
yeah.
So David, so you've just finished up chapter 4. So are you thinking that maybe you'll be finished with chapter 5 for next week?
Oh, I'm not making any promises, but I like to, yes. So I mentioned earlier that I went ahead, and I'm really curious what's coming. That I'm now going linear order, and I think I like to go advanced with chapter 5, and don't really know what's ahead. Maybe it's going to be hard, but according to some comments, it will be smooth sailing. So
yes, indeed. Yep. Right up until chapter 9, which we just touched on, and that. But once you've made it that far, it's like, okay, this is the section for people who are actually building the tools. You've made it through the people who are, the information that's for the people who are building applications. But of course, the more levels of abstraction you know, the better decisions you can make. So yeah, I think everybody should understand how the tools work. Like looking at the Concordant API. Knowing how the math works underneath that, it makes perfect sense, and I can make better decisions.
Actually, I've seen also tweets about Concordant, and actually went to their website. It was a few months ago, but I think now I know that I didn't have the understanding to appreciate actually what they do. So now with this little knowledge I learned from this book, I think I'm going to go back to the website, maybe read their API and see what they actually do, see with their application and the problem domain, because I think it's very interesting.
Yeah.
Do this.
But anyway, David, if you don't go too fast, you don't finish by in 2 weeks' time, then perhaps by the time that you finish chapter 9, I will be so far that I can start coding, and then we can work a little bit on the model together for the service worker app. But yeah, if you go too fast, then I will still not be there.
I keep going. That's I can promise, and then we'll see where I get.
Excellent. I appreciate that. Yeah, and I appreciate your time today. I think we're running close to the end of our hour.
Yeah.
So yeah, I will. I have updated, or I have not yet updated the site to extend the meetings. I like to make sure that things are going pretty well, and not just say forever, but yeah, pretty much forever at this time is what we're targeting until people get tired of it. So.
You have still a lot of work to do, so we will need your input, Michael.
Very good.
I hope we can start real coding as soon as possible.
Yeah.
But I think I'm almost that far.
Cool. Yeah, and things are happening on Janaga.js as well. So I might have an update next week with some exciting news there. Trying to get ready for the next round of conferences, and actually looking forward to the end of the year. Thinking maybe we can get back to some in-person conferences. So that's what I'm shooting.
Yeah. But then we cannot attend them.
Yeah, that's true. But
try to convince them to record the conferences.
Yeah. But at the very least, the preparation work that I'm doing for these conferences is something that I'll be sharing as well. So, so yeah, I think it'll all help.
Okay. Michael, thank you very much. David.
Thank you, Michael.
Thanks.
See you next time.
Okay.
Bye-bye.
See you. Bye-bye.